Good evening and welcome, my dear students. Today I'm going to bring about another physics practical experiment, that is the refraction of light through a glass slab. For that, we'll require a few things. I'll show you what are things required for this experiment before going about it. And a few things need to be known beforehand, like angle of incidence, angle of refraction, angle of emergence, angle of deviation, then incident ray, refracted ray, emergent ray, normal at the point of incidence, and of course the laws of refraction. So if you know those things, you can come up to this experiment, the practical experiment. Let's go about it. So before we start the experiment, let us see what are the things that will be required for this. You will require a rectangular glass block or a glass slab, 4 pins, we call them head pins, a pencil, a protractor, and a scale. Before we do the experiment, let us see what actually the experiment is. A ray of light, when it comes through this side or from this side in an oblique way, or at an angle of incidence, then the ray of light is bent towards the normal. So first, because the ray of light is going from the air to the denser medium of the glass, it bends towards the normal. Then it again emerges from the glass to air, so it bends away from the normal. So from that phenomenon, we can measure the angle of incidence and the angle of refraction for a number of set of readings, and from that we can calculate the refractive index of glass. That is the ultimate objective of the experiment. So let us first see what actually happens to the ray. After that, we'll go about doing the experiment with the head pins. Okay, so first let me show you what the experiment looks like. For that, I'll have to make it a little dark. So if I put the ray, you can see that the ray of light is traveling through the glass slab, and then it is bending at an angle, then it is again emerging out of the glass slab. Okay, the ray of light goes through the glass slab and it emerges out again from the glass slab. Now we will do the experiment, and for the experiment I will place a thicker glass slab so that it is easy to see the head pins through the glass. So now we start doing the experiment that is required for our examination purpose. That is the most important thing, right? First we place the glass block and draw the outline. We press it against the paper and we draw the outline of the rectangular glass slab. You can darken the lines. So this is the shape of the glass slab that we put. Now somewhere in the middle of the glass slab we need to construct a normal. So let us put this point over here and we will construct a normal at this point by considering a 90-degree angle. So this will be a 90-degree angle. Now we need to construct a few angles, and the measure of the angles are 10 degree, 20 degree, 30 degree, 40 degree, and 50 degree. But we need to construct them in alternate ways. First, we draw the 10-degree angle. Remember, the angle of incidence is measured always with respect to the normal. So if this is the normal, the 10-degree angle will be over here near the 80-degree mark. So this will be a 10-degree angle of incidence. This will be the incident ray that is at the 10 degree. So I'll write 10 degree over here. I'll not mark it here because it will become crowded. Then we construct the 20-degree angle to the right side, to the alternate side. Because if we draw on the same side, it will be a bit crowded. We place it like this. And the 20-degree will be somewhere here around the 70 mark because we are measuring it from the 90. So this is the 20-degree angle of incidence. And we draw here 20 degree. Then we construct another line, 30 degree. So alternate ways, we draw 10, 20, then 30. It will be around the 60 point mark. Then 40. Then 50. Remember, we are measuring from the 90-degree mark because it is the normal. This is the This is the 50-degree mark, angle of incidence or incident ray at 50 degree. This is the 40 degree and this is the 30 degree. So now the incident rays are drawn. Now we can place the glass slab over here like we did it before drawing the outline. We place the glass slab exactly the way we placed it before drawing the outline. Okay. Now what we need to do, we need to take 5 readings. First, we will do it at the 10 degree, then we'll do it at the 20 degree, then at 30 degree, 40 degree, 50 degree. I'll show you one of the 5 readings and you will be able to do the rest. Let us consider the 30 degree angle of incidence. So we place 2 pins, one pin here, the head pin over here at the 30 degree mark. Make sure that the pins are vertical and the pins are slightly away from each other to remove the parallax error. They must be away from each other, not very close to each other. Okay. Now what we have to do, we have to observe these 2 pins, head pins, through the glass slab, through the thickness of the glass slab from this side. Because the ray of light that comes from this pin and passes through this pin, that is the incident ray that we drew at the 30 degree mark, that ray will come here, fall at the point of incidence, it will bend towards the normal, it will again bend away from the normal at the point of emergence. So we are to observe these 2 pins from the emergent side in a way that the image of these 2 pins fall in the same vertical line with the real image of the with the real pins that we fixed over on the emergent side. The pins that we fixed over here are like the objects, and the image of them seen through the thickness of the glass slab should be observed, and with the image that we see through the glass slab must be coinciding with the pins that we fix on the emergent side. So now we'll do it from the observer's perspective. So now we come to the observer's perspective. When we see the 2 pins that we fixed on the other side, on the incident side, through the thickness of the glass slab, we will observe something like this. And we have to place the 3rd pin along a vertical line so that the 3rd pin comes in line. Make sure that the glass slab is not rotated. We have to place the 3rd pin such a way that it hides the other 2 pins behind it. That means When we observe it along a different line of direction, we will see 3 pins, but in a particular direction you will see just 1 pin. Then you will know that your observation is right. Now you see the incident pins, the 2 pins, the pink headed pins are hiding behind the blue pin. Now what we have to do, we have to take another pin and fix it in the same vertical line so that all the 4 pins appear as 1. Now see, through the thickness of the slab, if you will observe, the pins are appearing as a single line. That means your observation is correct. Okay. Now the observation points are taken. So we need to pull out the pins one by one and encircle the points. Make it D1, make it C1, this one. You can remove the glass slab now. Make it B1 and make it A1. So A1, B1 are the incident points, incident pins, pin marks, and C1 and D1 are the emergent pin marks. Now what you need to do, you need to join D1 and C1 and extend that line so that it touches the emergent face of the rectangular glass slab. Okay, so this is the emergent point. Now you join the emergent point to the incident point. You get the refracted ray. This is the incident angle, that is the 30 degree. This is slightly less than 30 degree. Let us measure it. Is about, let's see, it comes out to be about 21 degree. Okay, so we get 2 readings. One, the incident angle 30 degree, and this is the refracted angle or angle of refraction, that is 21 degree. We can mark here also in the emergent ray, but it is the angle over here. Then we need to repeat this experiment for 40 and 50, and before we did the 30 we need to do the 10 and 20 as well. I will not show you all the 5 readings, you just observed 1 reading. So this is, make sure that you give arrow marks on the real rays. This is the incident ray, the refracted ray, and the emergent ray. If you measure the emergent angle, it will be same as the incident angle. Now, from the practical exam point of view, what you need to do is that you need to make a table. You need to make a table, and in one column, you need to list the values of the angle of incidence, and in one column, the angles of refraction. And in another column, you write the values of the sine of the angles of incidence, and in another column, the sine of the angles of refraction. So this is I, this is R, this is sine I, this is sine R. So I will be fixed, it will be 10 degree, 20 degree, 30 degree, 40 degree, 40 degree, and 50 degree. Like we did the experiment in which we got, for 30 degree angle of incidence, we got 21 degree angle of refraction. 21 degree angle of refraction. So likewise, we'll get some values over here also. So for all those, we have to find the sines. The sine 10, sine 20, sine 30, sine 40, sine 50. Then sine of the angle of refraction corresponding to the 10 degree incidence. Like in this column, in this row, we have to find sine 21, and here sine 30. Then you have to make a graph. And in the graph, I'll show you here. In the graph, along the x-axis, you can take sine I. Along the y-axis, you can take sine R. So the sine I and sine R values will be the x coordinate and y coordinates respectively. Then you will plot the graph. Sine I value, sine R value, sine I value, sine R value, sine I value, sine R value. Like that, you'll get some coordinates, xy coordinates. And if you join the points of observation like that, you will get a straight line passing through the origin. All the points that you will get over here in this column, the sin I and sin r values, here there will be values, okay, not this expression. There will be some values in the calculator you will get, or in the trigonometric table also you can find. So all those values will give you some points, and it is not compulsory that all the points need to lie along a same straight line, because there are errors in our observation taking in our experiment. There will be errors always. So some points, if they lie outside the line, you need to draw an average line. That is what is expected from you. You need to draw the line which passes through most of the points, or the average line. And from the average line, you can calculate the refractive index. Suppose this is sin r axis, this is sin I axis. Then from the sin I by sin r, from any point on the graph, this will give you sin I, this will give you sin r value. So this value by this value will give you the refractive index, because refractive index is always sin I by sine of angular refraction. That gives you the value of mu. So hope you have understood this experiment. For more experiments, subscribe to my channel. Thank you and good night.